Okay, so here I am attempting to drill these pieces onto my flue here, and because this is hardened stainless steel, these self-tapping screws just ain't working. So I'm going to burn a hole in here. That. See what happens. Okay, that quick. There's my little hole, and that should drill right up now. I don't know if you'll be able to see this, but it is not. And it's tacked on anyway. Oops, sorry. Of course, I'll have to do the same thing to that there, but I'm going to shut him down. But it's definitely cool to just go around and tap my holes with this torch rather than trying to drill through this stuff. I know there are drill bits that do it, but I'm going to go ahead and do the same thing on this because you cannot drill through this stuff very easily at all. It's just a menace. So I'm going to wrap these little clips around here like this. We're going punk on this thing. Steampunk, I mean. I'm going to shroud that flue up, wrap it with a clamp, and show you guys what it looks like when it's done, and go over the process of what actually happened here. Because this is definitely way cooler than trying to drill holes. And just to get an idea, this is the size of the hydrogen torch I'm having to use to do this. I've been hitting it with just 15 amps, which is about 5 liters per minute. That gives me a good spray. And this is a number 5. Yeah, this is a number 5 tip on a micro torch. The hole's about that big for anyone that may be building their own, but I could go with a smaller tip and less amps, but sometimes the other pieces of metal interfere. I know if I hit it with 15 amps, I'm blasting through within seconds and the job's done. So it's a pretty cool little way of doing that. Just wanted to share that process. Steampunking along here. This is what I call rapid prototyping. We do not care what this thing looks like. We want to know if the design functions. Aesthetics come afterwards. That went on there about as quick as it would take to screw those together. Without that oxyhydrogen flame, I would not have been able to do this that quickly. Okay, I don't know how well this is going to work. I just wanted to show how fast these pop screws work. We're trying with less amps maybe. Hell with it. I'm just going 15 amps. Oh, I'm playing games. So basically, I know you're supposed to use protective eye covering, but what I'm doing is just closing my eyes and listening for the sound, basically. And that'll tell me when I'm burnt through. Yeah. There it goes. Normally doesn't take that long. That was a bad representation. See how easy that screw just goes right in there now? Right here real quick. Hear how quick that pops through? I can just fly around this whole thing now. Before it was just an absolute nightmare. Ruining a bunch of bits. All kinds of craziness going on. That one is not going through. There it goes. Yeah, I need to get some goggles. Open my eyes. A lot quicker on that. Now, I know this is pretty uglied up right now, but I'm going to pound that together, pound this together, drive a couple more screws here and there. But I just wanted to illustrate or demonstrate how fast that that worked. Now I know it didn't seem that fast to some of you who have used self-tapping screws before, but if you would have watched me try to just get this top piece on and this under piece, you would know why I decided to post this video. I am like shaving hours off of a job here with this process. So definitely one good use for oxyhydrogen gas. Well, there's that. Definitely went quick with that torch. You're wondering why I'm doing this? The way that it's being done, it's because I'm broke. Unfortunately, I couldn't show you this thing in operation because of patent law issues and something called prior art, or public domain, I believe is the terminology. But I can show you what happened to it. At this point you don't really know what it is. Basically, this experiment taught me that this screen system's not going to work. That is basically a bunch of tar and ash burnt into slag. So I believe that white stuff is a lot of the residue of the epoxy I used to hold this thing in place. I mean, it held up throughout the experiment, and from that sense it did its job, but definitely burnt right through that brass. I was curious as to whether or not that would hold up. Basically, I had a fireball shooting out of this thing about that far at some points, about 2 to 3 foot. So, pretty nice.